Yes, good morning, everyone. As per this, operational research has been considered. In the previous class, we have been gone regarding the genetic algorithm method and the application of this algorithm method for solving the typical kind of problems which will be coming under the linear programming technique for different kinds of transportation problems. And mostly, this method consists of two different categories, that is involvement of the time factor or time constraint, and without involvement of the time constraints. But as per the previous class, we'll be moving furtherly indeed to generate the optimal or feasible solutions in the case of transportation problems by utilizing the additional factors of techniques, that is random search method, mutation method, and optimization methods. Here, moving on with respect to an random search method, there is only one way to try to find out the optimal tour. Let's take the random sample. They generate a lot of random tours or tracks or route maps that are being developed as per the given source position to the destination position. Beyond that, we'll be finding out a feasible, nothing but a shortest distance point from the source to the destination position. We only need to enter only the two expressions, that is input and next the basic, that is destination point. The basic initialization with respect to a random tour in the form of programming nature. For instance, we have been considering of about 999 samples need to be tested, and only the one route map need to be analyzed among that 999. That means overall 999 times the operational process need to be scheduled, and depending upon that the process need to be performed. Related to that, the lowest time consuming, or in the case of distance factor, the distance occupation from the source to the destination as per the ARP statistics will be considered and will be identified in the utmost strategy. Here are the scenario or the terminal relation with respect to this tour and number of routes, that is which is greater than the best among the given n number of samples, that is m dot make underscore 2, and we'll be giving this 999, and among that one will be the greater than this overall 999, that results the factor of t, and hence t is the best in the case of cost if the cost has been given, or else if the distance has been given and will be replacing the distance in the place of this cost. That means whatever the constraint in the question that has been asked related to that, the factor will be getting changed in the formulation analysis. At that particular time, the variable which is named as the best contains the lowest cost tool. Yeah, here as per the budget, if you have been considered, the economical factor plays a major important role, and based upon that, the cost is a major constraint in the given problem, and among these 999 route maps or the tours which has been scheduled to a number of places within the India or apart from the India, will be identifying the least economical factor zone containing tour which will be scheduled out of the 1,000 random samples. So almost all this 1,000 will be verified and scheduled as per the formulation analysis given in the input, but only one among the 1,000 will be very much optimum as per this random search. And overall, these 1,000 need to be completed within a least time factor in the case of any processing zone, as this initial tour and the samples are displayed as follows. Considering the initial sample cost of 2134.26, as per the laboratory process, this transport generation problem related to get the analysis in between one city to the another city need to be track out the distance and even the route map which will be feasible for the movement between the city 1 and city 2 and city 3 and 4. Likewise, as per the schematical view, here the best tour out of these 1,000 random samples, which will be costing very much less, as the initial sample consists of 2134.26, that the origin of 0 to 1 relates to the cost of that tour, and from 1 to 2, and instead of moving from city 1 to city 2, there is an interlinkage factor which is the shortest distance that need to be identified in between, and rather than this two which charges an huge cost or huge amount for the traveling, will be seeking the possession of three from one city to the third city. Likewise, the mean distance which will be having very much less leads to a less economical factor that will be identified first without following the chronological order. Here the major constraint in the given problem it is the cost analysis or economical factor. So in such a way the distance will be categorized, and for example if you have been considered any of the vehicle, that will be charged based upon the distance. So from one city to another city, as per the Rubik Labs schematized the route map for the transportation problem. In the simulation process, indeed to characterize the least amount that is being taking place, indeed to cover the overall cities among this displayed screen, that is from 0 to most probably 9 cities are existing, and this almost all the cities need to be covered starting from the source point residence 0, and it will be occupying an own nature of analogy. And this is the track 1, and just we can analyze from the point of 0 it has been moving to 4 initially, and 4 to this point number 6, Here 0 to 4, 4 to 6, and then 6 to 3, and 3 to 1, and 1 to 7, and 7 to 5, and D from this 7 to 9, and then again back to the 5 again, and from here 2, and towards this 8, and next to the 3, and from this 3 to we can formulate 8 to the next point and next to the horizon point, and that cost of entire this route map costs of about 2134.26. And let us consider in our Indian standards, that is rupees, within the internal city. And another one more way, instead of moving from 0 to 4, directly there is an interlinkage from the origin point to the 9, and hence 0 to 9, 9 to 5, 5 to 2, and hence 2 to 8, and next to the 3, and 3 to the 5, and 5 to 7, and 7 to 1, and from here there's an 6, and next 6 to 4, and then 4 to 0. There's another one more track that we are having, and hence for this also it might be an cost or economical factor that is being taking place of 2134.26. And relating to the another one more way, this is the one path that is having second least in the economical factor among these 1000 samples or 1000 route maps or cities coverage. And considering another one more, which is occupying very much less when compared to this last but one. Here, if you have been identified, it is moving on from the origin to 4 to 5 to 7, next point number 2, or next 9, 9 to 8 to 1, 3, 6, and finally it is reaching towards the source position back again. So this is containing, instead of traveling much distance when compared to the previous analogy or previous route map, indeed to cover the overall from 0 to 9 cities, that is maximum 10 cities within the city, 10 places within the city. Sorry. So the cost of maximum of 1353.70. So these are the random search method. Among the existing n number of route maps will be picking up the shortest distance that is being occupied indeed to cover the overall 10 different places within a particular city. And generally, what is an natural selection as per our criteria? When you have been seen the given situations and situations, depending upon the situations, what is the analogy that will be coming into the mind? There's a general characterization will be seeing once. Coming to the natural selection characterizations, that is deleting of the tours in the process similar to the natural selection in the population biology. That is, most of it tours have lowest cost. The transportation problem, TSP lab, transportation selection lab, these tours are very much close to the front of the population array, that which shows the n number of route maps to us. And even this method is named as select survivors or iterates over the population. Nothing but iterates. We all are familiar with respect to this iteration process, that among the or the similar process will be performed by the similar process will be performed by n number of characterizations and obtaining the n number of results, where here the example has been given to us. The tour at the location I was deleted with probability of I divided by n, where n is the population size, that is nothing but n number of persons that people are performing the activity. As shown in the tabular column, the probability of deleting an object from this among 25 tours considering, including the 0 to 24, and hence 25 will be the overall number. The best tour is always kept as 1. And we have to note, or we have to be familiar that always poor tours also may be having some of the surveillance which will satisfy the given needs or conditions or constraints within the given problem. That is, have to touch the overall cities, but there will not be any time factor for this overall coverage of this distance. Another one more it is, if the time factor has been given, economical factor will be neglected in most of the cases. Simultaneously, as per the problems given to us, if the economical constraint has been given, time factor will be getting omitted. In some of the cases, both the factors need to be satisfied, and depending upon that, we have to solve the problems. Considering the display units or the sectors related to the natural problem, considering an source of 0 and need to cover the overall paths. If a map is being displayed on a Ruby slab car, it can modulate as per the statistics given in the display as a bar graph. A call to initial, that is the code of initial, that is INIT, initiation underscore population, will display a bar graph, and the height of the bar represents the cost of the tour. As per this bar, the cost will be scheduled, and you have to note that the low cost tours on the left, it will be existing, nothing but as per the stepwise format, the cost will be increased if the step rises towards the right and decreases to if the step which is having less in height when compared towards the left side direction of the geographical or the graph which is being representing. Next, here, if you have been given among the 10 different route maps, we need to find out what is the list, or indeed to arrange as per the economical basis in chronological order. It will be identifying in the stepwise format, which will be having the least cadre of the economical factor towards the left, and likewise intermediate and middle and slightly higher, and what is the maximum cost thing so that is being taken place in that particular city. You need to cover the n number of destination points existing. So based upon that, we have been already seen in the previous class, it is the heuristic problem. We have solved the heuristic problem for touching the overall 10 different cities within a 10 different places within a city. But not only 10, it may be increasing furtherly as per the criteria. And for that, calling the select underscore survivors, it will update the display based upon the route maps that has been analyzed in the process of iteration in the case of natural selection. That tours removed from the population will be colored, right? Which has been removed will be indicating with respect to the color coding, and without it, it is ideally specifying in the white color. So later on, the omitted characterizations will be deleted again and only the selected cadres as per the guidance required to the person need to be moved or selected will be analyzed based upon this rebuilding the population. So after the high cost tours are removed, the algorithm needs to refill this population once again. So that involves the following characterizations, that is moving all the survivors to the front of the array. For each attempt slot, have to make a copy of random survivors, adding a point mutation to the copy, insertion the copy into the array, like this. And after commencing these all characterizations, the method which is named for the commencement of this copying of random survivor and adding a point of mutation to the copy and insertion of this copy into the array is named as is rebuild underscore population. And then finally it will be displayed by updating as per the criteria by omitting these deleted cells or deleted slots, and new tours are on the right hand side of the histogram as it has been displayed. And we all aware of that, which is having the peak length will be having the high amount of cost, and which is having the least will be having this in the case of this altitude or height, having an less in the case of cost difference. And later on we can utilize another one more method, that is an e-search method. The operations described on the previous slides are all called by the method that is called e-search. So here E is nothing but an inquiry and inquiry search, right? And it relates to the HTTPS, that is an Internet Security or IoT basis Internet of Things, which will have a map which defines the cities and the distances between them. The two arguments or arguments will be passed in the case of this usage. First one, it is a map object which is defining with respect to the number of cities and the distance in between the cities, and the number of generations, that is number of rounds of selection founded by the rebuilding. For example, if you've been taken that 500 number of destination points, among that or 500 number of route maps, among that m, there is something but what is the best way of route map. So indeed to cover this 20 or 25 route maps for generating or mapping this overall destination points within a city, how many generations are being taken? There's nothing but 500 generations. For example, 500 route maps are existing. And how much time or how many tours are being existing? Among this 2309. And what will be the best generations that are being taking place with respect to and less cost effectiveness? So this method returns the best tour found after the specified number of generations. So among these 500 route maps of generations, you need to cover these overall 25 to 30 different destination points within a particular city. The iterative process or research process identifies 500 ways of generations or 500 ways of route maps in the case of guidance and the distance between one city to or one place within the city to another place in between this overall 25 to 30 different places. This is a case of this e-search method. Well, the point of these mutations, the difference between this random search method and genetic algorithm method. When we find a good tour, we'll try to improve it by adding some of the characterizations and as per the genetic conditions, we will assign some of the feelings within our mind. And if there is any further actions required, the mutation here crosses the conditions that in the following criteria, as we will be seeing just before. That is nothing but adopting terminology from the molecular biology changes the tools or called the mutations. A type of mutation that make a minimal change in a cell is a point mutation. Within that particular unit cell among the given overall roots or tools that will be identifying by our laboratory process, that is transportation search problem lab. The point mutation which is just need to be crossed, that changes the order in which two cities were visited. These two cities, almost after visiting, they will be identified as an these crossholders that already the visiting has been completed. The indication specifying that almost has been covered away. Going to the factor of the efficiency related to this e-search method, we can do some back of the envelope calculations to estimate many tour objects that are created by this e-search finding. So on generation of roughly there is half the tours which have been replaced among the, for example, we are considering this 100 different e-searches, 100 ways that have been obtained as per the research. We expect to create this 50 new tour objects on each generation. So we'll be obtaining an total number of tour objects was approximately considering of n plus g into n by 2, where n is the population size, g is the number of generations. So for example, for an n coding, n may be of 100 iterative process, or selected criteria is 100 among the 500 estimations. It leads towards into n by 2. And the search of on the previous slide, it is n is equal to 100, g is equal to 500. Examined only about 25,000 tour objects. It leads to generation of 25,000 tour objects, as in the previously you have been verified in the case of this mutation process. Another one is recap. So recalling it. So the traveling sales problem is very much complex to solve with a straightforward test and leads to generation of a map with 25 cities, which has over 3 to 10 to the power of 23 tours. Instead of examining these overall possible tours, there is a minimal option of selecting a random sample, which will be identifying the return at once with the lowest cost. So it will be an decreasing in process or the EVS of searching process among the all possible route maps. Hence, this RSH method, the recap method, leads to generate only the lowest cost analysis route generations. And even it is very much inspired in the case of ideology for selecting this optimal tour by looking at four examples. There is a simulation of n generations. As we have been re- seen in the ESH method, by looking at only 25,000 out of this 3 into 10 to the power of 23 possible tours, this ESH was able to find out what might be the optimal tour. So among this overall 25,000 out of this 3 into 10 to the power of 23 leads to find out only the one optimal tool. So what will be considered here? So optimization plays a major role. So we'll be just looking after what is meant by optimization and what is that optimization problem or route identified at that particular condition and how it has been analyzed. We'll be having a detailed look. The traveling salesman problem is an example considering the main optimization is nothing but the best route map which is having with a high efficiency considering with less economical factor or overall the input factors. By giving an less input factors need to be identified much more output in simple form. For example, economical factor need to be we are seeing that n number of destination points need to be covered within a city. For example, 25. So less distance occupying, less time factor consuming, less economical factor consuming. What is the best route that is being existing among the n number of possible ways indeed to cover this overall points among these 25 cities, 25 places within a city need to be covered. So only one will be very much less and remaining will be in slight variations with it and some of the route maps generates and very much high in the case of economical factor or distance factor or time factor considered. So definitely it is these three parameters are interlinked to each other. If the distance has been increased, obviously the time consuming or time bound is very much more, and obviously if time and the distance is being increased, obviously the economical factor is also very much high because we are all aware of the conditions that the distance is being increased indeed to travel by utilizing a vehicle. The consumption of fuel also plays more. So the cost effective for this fuel will be very much high indeed to cover the large distances. And even as per the time factor, it is very much more time consuming when compared to the least case of problems or root maps. Hence, the main goal is to find a combination of parameters which gives an highest or lowest value for a function. So we'll be analyzing an least value with an slight frequency variation within the graphical representation and moving on to the maximum value which is getting at an peak stage or highest value in the graphical representation. Further, we are considering two different constraints that generates, and among that the functionality will be getting developed and that functionality value will be identified. So what values of we are considering here lowest value and highest value as an x comma y, and what are the values of these x and y gives the highest value of the function. So considering both of these strategies as a function and relating that maximum value to the set and what will be the highest value of the function, we'll be having an detailed look here, considering with respect to a problem that need to be collected by n boxes towards the 2 power n combinations. And as you have been already discussed with respect to the heuristical theory, finding the optimal set of boxes required in genetic algorithm for some other type of heuristic search. Here we will be considering one of the example of bin picking. Here a goal has been given to it that choosing a set of packages that will fill the most space on a truck. The greedy algorithm puts boxes, the egg boxes on first for occupying less volumet- volumetric condition within the wagon. Here, a better choice includes a lot of smaller boxes and algorithm that potentially has to examine all the combinations. That is, loading the mini boxes first time and later on the small boxes, large boxes, or else the secondary condition, initially loading the large boxes and later on the small boxes which are having the highest number will be placed later and medium range will be fixed or on and combination that as per the volumetric efficiency within the wagon, some of the large boxes and next as per the volume existing, the small boxes will be kept in between. So likewise, how many number of possibility ways are existing will be analyzed, and based upon that, as per the heuristic search, we'll be finding the optimal solution among the given conditions. Here, the major constraints are the space that is being occupied by n number of boxes, and that will be overcoming with respect to an arrangement, and that arrangement, the type of arrangement will be coming to the mindset of a particular person who is working at that particular point that need to be loading in condition, because this loading involves that some of the small boxes and combination of the smaller boxes and larger boxes, and on an average of overall loading conditions need to be distributed at different destination points, and based upon that at that each and every points of destination, both these smaller boxes and the large boxes may be involving, or else only the large boxes may be involving, and only the small boxes may be involving. So these had to be analyzed as per the roadmap that has been generated in the previous algorithms we have been seen. And likewise, the setting will be tracked out, or like that the overall packing boxes will be stored in the wagon. And initially, what's the place or destination will be obtained, and it has to be unloaded, and later on vice versa, overall destination points need to be commenced. So this is the optimal solution need to be generated based upon the both loading and unloading, and what are the constraints that are having in the case of this heuristic search. First one, it is a time factor. Next one, it is an economical factor, and the third one, it is the volumetric space that is being existing, and fourth one, it is what are the type of boxes that need to be unloaded at each and every destination point. And based upon that, as per the volumetric constraint, the loading condition need to be characterized, and it should be very much flexible for unloading at each and every destination points. All right, this is a heuristic search which is having a less risk effective process in the our optimization problems or heuristic search methodologies. Right, thank you. We'll be meeting in another class with another topic.